Hi everyone, in this video we are going to take a deeper look at the ozone layer. So the ozone layer is the bottom half of the stratosphere. So let's draw the stratosphere out. The stratosphere is our second layer of our atmosphere. It's above the troposphere and it's below the mesosphere. So the stratosphere starts at mile 9.3 and it goes all the way up to mile 31. The ozone layer is actually the bottom half of the stratosphere. So it's this section right here. And so it runs from mile 9.3 to about 18.6. So this whole section right here is our ozone layer. Now, what's really interesting is that we've come to find out that 90%, so 90% of Earth's ozone exists in that ozone layer. But before I dive any deeper into this, I want to ask you a question. Is that a good or a bad thing? So, is ozone good or bad in the stratosphere? Easy question, right? Good luck. All right, did we get an answer? Hopefully we did, because we've talked about this a couple different times, but ozone is definitely good for our stratosphere. It is so good for us, and the reason why is because the ozone comes in and it protects Earth, and more importantly, all of its inhabitants from harmful UV rays. So now, UV rays we've talked about, those are considered ultraviolet rays. UV is just a shorthand notation for it. But when I talk about Earth, what I really want to be pointing out is we have three different groups here. So we can talk about plants, we can talk about animals, so maybe a turtle, a frog, or even a dog, and we can also talk about humans. So in 2015, right now, what we as scientists think is that the humans are the ones that are most vulnerable to these holes in our ozone layer. But realistically, the plants and animals have been able to adapt and evolve, and we really haven't seen very many negative issues with plants and animals. The biggest trend that we notice is that certain plants bloom in different seasons now. And so maybe they normally bloom in the summer, well now from the past couple years they're actually starting to bloom in the fall or something of that sort. The main reason that's an issue is because there are certain animals that feed off of these plants, and if the plants aren't in bloom then they can't eat the plants, and so there's kind of a bit of a downfall for that. But for the most part, the plants and animals seem to be doing okay. Unfortunately, it's humans that are the ones that are mostly affected about it. But let's go back to the ozone production, because what we want to see is if it's possible to naturally produce ozone. And it turns out we can. And so what's really neat about this is that we can actually go from oxygen, which is typically considered a fairly stable molecule. So if we take 3 oxygens, we can actually convert that to 2 different ozone molecules. So we go from 3 oxygen molecules, the diatomic oxygen, to 2 ozone molecules. But in order for this to happen, we have to put in a ton of energy. This is never going to just happen. You're never going to spontaneously have regular old oxygen just morph into ozone. The only way this is going to happen is by putting energy into the system. And most of the time when we do this or when we experience this, the energy is a result of an electrical discharge. An electrical discharge. So we've talked about this for a couple different pieces. Printers is a common one, that's where we see it from, or any type of welding or electrical equipment, that's a big part where we can have it. Natural causes are when you have lightning strike. Okay, and so all of these things can create the ozone in our atmosphere. And so when we have lightning high up in the atmosphere, it's actually great because we can convert oxygen to ozone, add more ozone into that atmosphere, add more into that ozone layer, and we can protect our planet. So here's the thing. How do we know how much ozone we have? How do we know that 90% of it exists in the ozone layer? Well, there are 3 different ways of measuring ozone, or 3 main ways, I should say. There's a lot of different ways. The first one, so back in the 1920s, this was actually established by a guy named Dobson, and so the unit for ozone measurement is actually named after him, but we'll get to that later. And so what he decided is that you can actually measure UV radiation to infer some information about ozone concentration. So what he suggested is that we measure UV radiation on Earth to determine our ozone concentration. So remember, these brackets just mean concentration. So the way they did that, and you have to kind of picture this as a very, very long column. So here's your column, okay? At the very bottom, here's Earth. And so we have our couple layers. We have the troposphere, we have our stratosphere, we have our mesosphere. And so what they can do is they measure down here. We try to figure out how much UV radiation is actually hitting the Earth. And what we can do then is infer what's going on with our ozone molecules directly above it. But if you ever hear something called like a vertical column or an ozone column, this is what they're talking about. It's a thin sliver of our atmosphere all the way from the top all the way down to the ground. And so what you can do is if you measure UV radiation down here, so you measure UV radiation, you can determine a lot about that ozone concentration. So if your UV radiation is really, really high, so you have a high amount of UV rays that are hitting the Earth, that must mean that you have a low ozone concentration, which is a bad thing, right? We do not want a lot of UV rays hitting Earth. However, if we have very low amounts of UV radiation, that means that we have a very, very high concentration of ozone in our stratosphere. So that is a very, very good thing. And so Dobson came up with this as a way to kind of measure one thing and find something out, maybe extrapolate out to find about the ozone concentration. So it's really neat. It's considered kind of a dated method, but it's originally how we started to figure out about ozone in the ozone layer. The second one, which is even more important, is we use weather balloons. Okay, so weather balloons, that's kind of common. What's actually a little bit more common is we use high-flying aircrafts. So a plane, right? High-flying aircrafts. And so just to give you a point of measurement, a typical plane will fly anywhere between 5 to 7 miles above Earth. And so remember, the stratosphere, that ozone layer, actually starts at about 9 miles. So your plane is flying down here, your weather balloons are down here. So the same way, they're trying to get information about that vertical column, trying to guess essentially what the concentration of ozone is based on information they take down here. And so what was really cool was that in the 1970s, when we started to really get a grasp on space travel, we started doing measurements from the upper atmosphere. And this is just so cool, so cool. So we have this thing called limb viewing. Limb viewing. So limb viewing is not really clear if I just told you the phrase, but essentially what it is you have planet Earth like this. Okay, so here's Earth, and here's some kind of spacecraft. I don't know how to draw a spacecraft, so we're just going to draw a box with a smile in it. So we've got people flying around, and there's spacecraft. So limb viewing is a way to look at the planet Earth from essentially a horizontal viewpoint. So you're looking from your spacecraft, and this is just the way you're looking at it. So you can see the top of Earth, or the atmosphere of Earth, but you're not looking straight down on Earth, if that makes sense. So here's your Earth, your spacecraft's over here, you're looking this way, so past the Earth, but your spacecraft is not directly above it, you're not looking straight down. And so in case my picture wasn't a good enough drawing, here's an actual real description of it. And so what you can see is you've got the Earth down here. Here's your Earth. You have your spacecraft, which obviously that looks much better than what I drew. And you have a horizontal view. So it's looking across the Earth, but not down on it. And when you do this, you can actually determine a lot of information, and you can, in fact, see the ozone layer. Here's a big misconception. People call it an ozone layer. So students are thinking, oh, it's this thick, thick thing that goes straight across the atmosphere. That's not true. That's a big misconception. It's actually very, very thin. So that's all we have for this video. Good luck. Take care of yourself. Drink water.